In this video, we'll take a look at parallel lines and transversals and the angles that are created. First, let's talk about parallel lines and skew lines. If you have lines that intersect and are coplanar, then they're intersecting lines. But if we have lines that do not intersect, we'll take a look at that. They can either be parallel or they can be skew. Parallel lines are coplanar, they're on the same plane, and we use this little arrow marker to show the two lines are parallel. We can also use these two parallel lines to symbolize parallel lines M and N. So for example, M is parallel to N. I've got the two little arrows on there to show it. I could also write it M parallel to N. Skew lines are lines that are not coplanar and they do not intersect. So let's take a look at our picture here. For example, line N and line K intersect. So they're intersecting lines. They're not coplanar. They're on two different planes. Line M and K are not on the same plane, and they do not intersect. They would be skew lines. So we have lines that intersect, line N and line K. We have lines that are parallel, M and N. We have the lines that are skew, M and K. And we have parallel planes. Plane T is parallel to plane U, and you can see that with this marking there. Think of each segment in the figure as part of a line. So each of these little edges is part of a line. And we'll see if we can find lines parallel to CD and containing point A. So here's CD, a line that's parallel to it. Could be this one, could be this one, maybe this one, but it has to contain point A. That's going to be line AB. A line that is skew to CD. So here's CD. A skew line is not going to intersect this at all, and it won't be parallel to it. So if you're thinking maybe AG, that would work. Also AH would also be a skew to line CD. Lines perpendicular to CD and containing point A. Perpendicular means they intersect at a right angle. So here's CD. If it contains point A, then this line, DA, will be perpendicular to it. And planes that are parallel to plane EFG. So let's look at where EFG is. EFG, it's kind of the bottom of the box. Parallel planes to that, containing point A, would be plane A, B, C. If two lines are in the same plane, then they are either parallel or they intersect at a point. Through a point that's not on a line, there exists exactly one line that will be parallel to the line. Through a point that's not on the line. So let's say we have a line, and we'll call it AB. And we have a point C. It's not on the line. I can only draw one line through point C that will be exactly parallel to line AB. So these lines would be then parallel. We have a parallel postulate. If there is a line and a point not on the line, then there's exactly one line through the point parallel to the given line, which is what we just illustrated. We also have the perpendicular postulate. If there is a line and a point that's not on the line, then there is exactly one line through the point that will be perpendicular to the original given line. A transversal is a line that intersects two or more coplanar lines at different points. So here we have two coplanar lines, and this third line here is called the transversal. It is intersecting both of the other two lines at different points. When we do this, we kind of create this box. And we have the interior of the box, or we have the outerior or the exterior of the box. Interior angles are inside of the two lines, exterior outside the two lines. We also have alternating. Alternate angles are on either side of the transversal. So 3 is alternate to 4, 5 is alternate to 6. And we have consecutive angles. They're on the same side. 3 and 5 are consecutive. 4 and 6 are consecutive. Angles and transversals, there's some relationships that occur there. You can have corresponding angles. Corresponding angles are going to be in the same position on each of the two lines. So if we look at angle 2 here, it's kind of sitting on top of the line and to the right of the transversal. Angle 6 is also sitting on top of the line and to the right of the transversal. Alternate, exterior. Alternating means on either side of the line of the transversal, and exterior is outside of the two lines. So angle 1 is alternate to angle 8, opposite sides, and also outside of the two lines. We have alternate interior angles. Again, here's our box inside the lines and on alternating sides. And you have consecutive interior. These are inside the box, but on the same side of that transversal line. Take a moment to see if you can identify all the different kinds of angles from our picture here. For example, corresponding angles might be 2 and 6. Interior angles could be 3 and 4. Alternate interior angles, 3 and 6. Consecutive interior angles, 3 with 5. Exterior angles, 1 and 2. If we go alternate exterior angles, I could say 1 and 8. Vertical angles, remember that from last unit, 2 and 3, 5 and 8, 6 and 7, 1 and 4. Supplementary angles, 1 with 2, 1 with 3, and so on and so forth. Can you classify these angles? See what you remember. Always want to kind of draw your box and decide if they're in the box or outside the box. Are they on the same line, same side, or outside? So our first example, we have corresponding, same side of the transversal and in the same position. Here we have alternate exterior angles, opposite sides of the transversal and outside the box. And lastly, alternate interior angles. The same types of angles are formed when we have parallel lines, and there's something that we can recognize then with their angle measures as well. The red dots show interior angles lying inside the parallel lines. Our blue dots are showing exterior angles that lie outside the parallel lines. Green is for those alternate interior angles, 4 and 6, but also 3 and 5. Purple is showing alternate exterior angles, 2 and 8, but also 1 and 7. Corresponding angles, 1 with 5, we could say 2 and 6, 4 with 8, or 3 with 7. Now, when you have parallel lines, you've got some angles that are going to either be supplementary or congruent. Vertical angles are congruent. So 1 and 3, 5 with 7, 6 with 8, 4 and 2. Those are vertical angles. Corresponding angles are also congruent. So if I move my little yellow marker over here, angle 1 corresponds with angle 5. their corresponding angles. They have the same measure. Same thing with 7 and 2. Alternate interior angles are congruent. So if I take a look at alternate interior angles, angle 3, or angle 6, I should say, and angle 4, let's see, can I move that around? Here's angle 4. Almost got it. There we go. These are alternate interior angles. They will be congruent. Same thing with 5 and 3. They're alternate interior. They're also congruent. We can see the same for alternating exterior angles. Angle 2 and angle 8 will be congruent. Angle 1 with angle 7 will be congruent. So these are all the reasons why, or reasons that we have congruency, but we also have supplementary. So 1 and 2 are going to be supplementary to each other. 1 and 4, and so on and so forth. Consecutive interior angles are also supplementary to each other. So angle 4 and angle 5 are supplementary to each other. They're consecutive interior. Same thing with 3 and 6. They will be supplementary. We have several different theorems and postulates. Got corresponding angle postulate. Again, if 2 parallel lines are cut by a transversal, then the pair of corresponding angles are congruent. The alternate interior angle theorem. If 2 parallel lines are cut by a transversal, then the pair of alternate interior angles are congruent. Alternate exterior angles theorem. If 2 parallel lines are cut by a transversal, then the pair of alternate exterior angles are congruent. And we have the consecutive interior angles theorem. If 2 parallel lines are cut by a transversal, then pairs of consecutive interior angles are supplementary. We do have a proof for each of these, so take a moment to pause the video. We have P and Q parallel, that's given. Angle 1 is congruent to angle 3 because of corresponding angle postulate. Angle 3 is congruent to angle 2 because of the vertical angle congruence theorem. Therefore, angle 1 is congruent to angle 2 because of the transitive property of congruence, or transitive theorem of congruence. Alternate exterior angle proof. Again, P and Q are parallel. 1 is congruent to 3, corresponding angle postulate. 2 is congruent to 3, vertical angle congruence theorem. 1 is congruent to angle 2, transitive theorem of congruence. Consecutive interior angle theorem, it's a little bit different. We've got N and P are parallel. 1 is congruent to 3, alternate interior angle theorem. 2 and 3 are supplementary. That's the definition of a linear pair, or you could say the linear pair postulate. And then we're going with 1 and 2 are supplementary by substitution. You try. So we need to find the value of x. So we'll take a look at what we know. And this number 4 is just representing the angle. We had 1, 2, 3, and 4. So this is not a value in the angle. But we want to take a look at what we know. Angle, this one up here, 115, that's going to be congruent to this angle here because they are corresponding angles. So I'm going to put 115 in here. If I know that's 115, then this angle of 115 and this one of x plus 5 will equal 180 because they are a linear pair. So I can start off by doing something like this. And then solving. I get 120 plus x equals 180. Subtract 120. We'll get 60. My x is 60. It helps to know the relationships and how you can set these things up. If the measure of angle 1 is 105, find the other angles. So angle 1 is over here, so that's 105. I know vertical angles are congruent, so this is also 105. Corresponding angles are congruent, so I know that angle 5 is also 105. And angle 8 is also 105. If you know one angle in one of these drawings, then you should be able to find all the other angles that you need. So this is toothbrush example. We have parallel lines here on our toothbrush holder, so I'm going to mark those parallel. And you have all the angles marked in here. Each one of these questions is a new question, so we kind of reset the drawing. If the measure of angle 4 is 65, then what's the measure of angle 1? Vertical angles are congruent, 65 degrees. If number 7 is 110, what's angle 2? These are alternate exterior angles, so it will also be 110 degrees. If angle 5 is 71, what's the measure of angle 4? 5 and 4 are alternate interior angles, so it will also be 71 degrees. If angle 3 is 117, what's the measure of angle 5? Well, this relationship is consecutive interior, so they're not congruent, but they do add up. So this is the measure of angle 5. They will add up to 180 degrees. So I think when we subtract 117, the measure of angle 5 will be 63 degrees. If the measure of angle 8 is 54, what's the measure of angle 1? These are alternate exterior angles. They will have the same measure.